A warm welcome you all. Today we are discussing about breakdown in composite dielectrics. Presented by Professor M. Chibin, Assistant Professor of Electrical Department, Rohini College of Engineering and Technology. Breakdown in composite dielectrics. It is difficult to imagine a complete insulation system in an electrical equipment which does not consist of more than one type of insulation. If an insulation system as a whole is considered, it will be found that more than one insulating material is used. These different materials can be in parallel with each other, such as air or SF6 gas in parallel with solid insulation or in series with one another. Such insulation systems are called breakdown in composite dielectrics. What are the properties of composite dielectrics? Breakdown in composite dielectrics generally consists of a large number of layers arranged one over the other. This is called layered construction and is widely used in cables, capacitors, and transformers. Mechanisms of breakdown in composite dielectrics. As mentioned in the earlier section, if dielectric losses are low, the cumulative heat produced will be low and thermal breakdown will not occur. However, several other factors can cause short and long time breakdown. What is short time breakdown? If the electrical field stresses are very high, failure may occur in seconds or even faster without any substantial damage to the insulating surface prior to breakdown. It has been observed that breakdown results from one or more discharges when the applied voltage is close to the observed breakdown value. There exists a critical stress in the volume of the dielectric at which discharges of a given magnitude can enter the insulation from the surface and propagate rapidly into its volume to cause breakdown. What is long-term breakdown? Long-term breakdown is also called the aging of insulation. The principal effects responsible for the aging of the insulation, which eventually leads to breakdown, arise from the thermal process and partial discharges. Partial discharges normally occur within the volume of the composite insulation systems. In addition, the charge accumulation and conduction on the surface of the insulation also contributes significantly towards the aging and failure of insulation. Aging and breakdown due to partial discharges. During the manufacture of composite insulation, gas-filled cavities will be present within the dielectric or adjacent to the interface between the conductor and the dielectric. When a voltage is applied to such a system, discharges occur within the gas-filled cavities. These discharges are called the partial discharges and involve the transfer of electric charge between the 2 points in sufficient quantity to cause the discharge of a local capacitance. The degree of aging depends on the discharge inception voltage VI and the discharge magnitude. It has been shown that VI is strongly dependent on the permittivity of the dielectric epsilon R and the thickness of the cavities gravity. dV by dg equal to epsilon r minus 1 divided by epsilon r into Eg plus g plus c divided by epsilon r minus 1. Here Eg is always positive and dE by dg is always negative or 0. In obtaining the above expressions, two assumptions have been made. One is that in the cavity the stress Eg equal to epsilon r, E where is the electric field across the dielectric, the other is sitting within the cavity, Eg max divided by Eg equal to 1. From the above analysis, the following conclusions can be arrived. For very small cavities, Vi decreases as the cavity depth increases. In spite of the erosion in the cavity walls, breakdown will not occur and the life of the insulation is very long if the applied voltage is less than 2 Vi. For applied voltages greater than 2 Vi, the erosion is faster and therefore aging of the insulation is quicker. Aging and breakdown due to accumulation of charges on insulator surfaces. During discharges at the solid or liquid or solid gas or solid vacuum interfaces, certain quantity of charge gets deposited on the solid insulator surface. Charges that exist in the surface conductivity are due to the discharges themselves, such that changes in discharge magnitude will occur spontaneously during the life of a dielectric. This is the breakdown in composite dielectrics. Thank you.